electric potential. First let us discuss about your work done. So you can consider the uniform electric field E vector and the unit positive charge Q in the field. If a test charge is moved from one point to another point in the electric field, there is a force which is act on the test charge due to the electric field, and this field is given by E vector is equal to F vector divided by Q. From that we can write F vector is equal to a product of Q into E vector. So if there is a movement of a charge in the electric field from one point to another point, then there will be a maximum work will be done against the force. There is a movement of a charge in the electric field from one point to another point, so the work done can be written as force into distance. So the differential work done is equal to minus of F vector dot dr, where the negative sign indicates the force and the work done are opposite in direction. So we know that F is equal to Q into E. You can substitute in this equation. So dW is equal to minus of Q into E into dr. If you want the total work done, we have to make a integration over the distance R1 and R2. So W is equal to minus of Q into R1 to R2 or X1 to X2 E vector dot dr. Next, let us calculate the potential difference. The work done in moving a positive charge from one point to another point in the electric field is given by, basically the potential is defined as work done per unit charge. So we know that the W is equal to minus of Q into R1 to R2 E vector dot dr. So the value of V may become minus of Q into, in the place of a W you can substitute this value. So denominator also we have a Q, and Q get cancelled, so V is equal to minus of integral E vector dot dl. In other words, or in other form, we can write dV is equal to minus of E into dr vector. Now let us move to calculate for a point charge. So we know that the electric potential or electric representation, E vector is equal to Q divided by 4 pi epsilon into R square into AR vector, and dr is equal to dr into UR vector. Now you can substitute the corresponding parameters. ER into dr is equal to Q divided by 4 pi epsilon into R square into dr. If you want the total value or potential, V is equal to minus of R1 to R2 Q divided by 4 pi epsilon R square into dr. Take the Q divided by 4 pi epsilon as a common term. Integration of R1 to R2 1 divided by R square. So this may become 1 minus of 1 divided by R, and you can proceed the lower and upper limit. So we can get Q divided by 4 pi epsilon R2 minus Q divided by 4 pi epsilon R1. It shows its value of a potential of a point charge, that is V is equal to V2 minus V1. In general, V is equal to Q divided by 4 pi epsilon into R volts.